Hey, hello, and welcome to another episode of JP's Product Pick of the Week. It's me, JP, and here we are to have a look at a product that I think is so stupendous, a new product that you might want to check it out yourself. Something new this week. We are experimenting with special pricing on the Product Pick of the Week during the live stream only. And if you head to the product page for this week's product pick, which I will reveal momentarily if you haven't figured it out yet from that little thing written right there, you'll get a discounted price. So, in fact, what I'm going to do is let's go completely out of order and let's reveal what this product is. Then we'll kind of go back and do things in the normal order. But I'm dying to go check out the page. So let's head to my Chrome cam here, and there you can see the product page for the AHT20 Temperature and Humidity Sensor. And what I'm going to do is I'm going to reload the page. Look! It's $4.05 instead of $4.50. And that is a special sale right now, only during this live stream. I apologize if you're watching this later, time shifted like a TiVo-raised person, because you want to see this now live while we've got special pricing. And so that's something we're going to test out and hopefully continue to do going forward. You know, 10%'s 10%. Sometimes our items cost more, sometimes they cost less, but this one right now, heck, $4.50 instead, now it's $4.05, not bad. So let's now jump back as if I hadn't done any of that stuff, and let's take a look at a little bit about this one. So I mentioned it's the AHT20. It's a temperature and a humidity sensor, and no one better than Lady Ada herself to intro this. So I'm going to jump back a little bit to, I believe, June when we released this. This is the new product, new segment from Ask an Engineer. Take it away, Lady Ada.
Okay. And then last up to start the show, besides the community and our Adafruit team members and all of you in the chat, is
the AHT20. This is from the same company that actually makes the DHT series sensors, and we've used those a lot. But they're a little finicky, especially on single board computers. What's nice about this sensor is it's got better quality than the DHT22, but it's I2C and it's a lower price. So really, I recommend people, if you were thinking of doing a product with a DHT22, upgrade to the AHT20 because you'll get I2C. It's so easy to use. It's 5-volt compatible, 3-volt compatible. We made this little breakout for you. Here it is plugged into our STM32F2 using this plug-and-play cable, displaying the temperature and humidity. It's so easy, and it's a great little sensor. If you want, higher precision, we have that. But if you just need a general purpose temperature humidity sensor, we've got code for Python, Arduino, Circuit Pythons. This is great for use with your single board computer, your Raspberry Pi. You can use it with your computer when you use like our Circuit Python adapters, like the FT232H or the MCP221. Works, of course, great with Arduino. So a lovely little sensor. I like it because I think it'll be very popular.
You can elaborate further later in the questions, but
yeah.
Why is there a little cutout around there?
Well, we had space because it's a 3 or 5 volt sensor, so I didn't have to use a logic level shifter. I usually do to protect against 5 volt input on like Arduino Uno. And so to isolate this from the rest of the PCB, what that means is that this little area here will heat up faster. So if I put my finger on it, you see it reacts very quickly because you don't have this gigantic ground plane or this PCB that's insulating it. It absorbs heat. It both absorbs and releases heat a lot easier because the resistance is lower.
Okay. All right. And with that,
All right, very cool. So one thing that was mentioned there is this is a Stemma board. This is actually a Stemma QT board, or QT. So what does that mean? Well, Stemma is our series of plug-and-play boards that have a couple of different plug types. There's larger 3-pin and 4-pin plugs, and there's also these tiny 4-pin plugs. Those are compatible with the SparkFun Quick system. And then we also have cables that allow us to go between systems. So this is an I2C board, and our Stemma QT is all about I2C, which makes it easy to plug in lots of peripherals. And in this case, I'm going to actually demo it where we're using an adapter cable to go between the larger JST PH and the smaller JST SH, which is Stemma to Stemma QT. Let's have a look at that board, by the way. I think where did I put it? I put a nice graphic up here somewhere of the board. There it is, the AHT20 Temperature and Humidity Sensor. One thing that I also wanted to mention regarding Stemma is that we have got now over 50 Stemma boards. So this is a sort of really nice growing system of boards, and I really like systems of things. So the ability to plug multiple of these in without having to think too much is wonderful. I'm going to demonstrate it. Like I said, I'm using a Pi badge, which has a Stemma 4-pin Stemma PH on it, so we'll use the adapter. But what about this sensor itself? So a couple of things I wanted to mention or reiterate that Lady Ada mentioned there. One is this is a all right, this may I may have gotten this back up and running. So sorry about that. We had a little crash happen with Wirecast. So let's see what's going on. I think the live stream is buffered and caught up probably. So bear with me one second. I'm just going to check in on Discord and see if that's running for people. Again, it might take a moment for YouTube to catch up. It should be live on Twitch and hopefully over on Facebook and some of the others as well. Let's have a look. Yeah, it looks like it's still running. Okay, YouTube's back up. Okay, so sorry about that. I'm going to avoid that large image. In fact, I'm just going to quickly do a save as of this session so it doesn't dump those settings again. Right, little inner workings here. You can tell this is live because these things happen. All right. So what I was going to say, let's go to this possibly safer, smaller image here of the board. It's too powerful. So the AHT20, this is a easy to use temperature and humidity sensor. It's got the Stemma QT connectors, so you can pass through, connect it to a board or another, a microcontroller or another Stemma QT board. You'll also notice it has the little cutout there. So this cutout that you see in the center is helping to isolate the sensor, that little package with the sort of silver top on it. That's the sensor package itself, and by isolating it a bit from having a large circuit board underneath there or copper plane, it can react faster to changes in temperature and humidity without worrying about as much of the temperature of the board. We get a little more about the ambient temperature, which is usually what we want. Let's see, other things I wanted to mention about this board. It is tolerant of both 3 volt and 5 volt, which is really nice because we can use either 3 or 5 coming from a lot of different microcontrollers over our I2C. And like Lady Ada said, usually she will put that voltage regulator on the Stemma QT board itself, but it's not necessary in this case because the chip can deal with either, which is really nice. And that's also what gave us the room to mill that slot. We have libraries for CircuitPython and Arduino that make it really easy to use. And so what I'd like to do, in fact, is prove it. Let's go ahead and take a look at this item. I'm going to go get it from the shelf of wonders here in 1 second. Let's head on over. one issue we had with that crash is that we don't have the right video in there. So apologies there for not getting to see the mystery cabinet that you wanted to see. But guess what? I've got it right here. This is it. This is the AHT20. And what I'll do is I'll show it to you on my overhead here. Let's swap to that. There we go. I've just got this little 3D printed hang tag on here, but that's the board itself minus the red plastic part. And what I'm going to do is I'm going to go ahead and take my Pi badge and plug this in over this Stemma cable. So you'll see here, this is one of the ones that goes from a Stemma full size to the Stemma QT size, both 4-pin. And this is going to allow me to use I2C devices on the Pi badge. So I'll go ahead and plug that in. Either one, it doesn't matter, and you can pass through to other boards if you like. And now what I'll do is I'll turn on my Pi badge, and you'll see here I've got my humidity sensor is already up and running, and it's reading it out. I wrote some simple code in CircuitPython to display the humidity of that sensor right there. And what you'll see is if I take this little sensor and I breathe on it, kind of like you fog a mirror, I'm going to go ahead and fog it and watch this humidity change as I add moisture to the air. You can see very quickly we've taken it up to 100% humidity, and then the dry air here drops it back down very quickly to essentially my ambient humidity. And that's the relative humidity percentage. Now what we can also do, since this is a Pi badge and I want to use the buttons, because why not, if I hit the A button, now I'm switching over to temperature. And you can see this is my ambient temperature. It's 29 degrees Celsius, and I've programmed this so that I can use my up and down, oh no, it's rather my left and right buttons, there we go, left and right, to switch between Fahrenheit and centigrade, or Fahrenheit and Celsius. So it's 84 degrees here right now. And again, you'll see if I put my finger on this sensor, that temperature will start to go up. Now, one of the ideas I had for a type of project you might want to do using this sensor is a 3D printer filament storage bin. So I have just a sort of typical plastic bin here right now. And one thing people do is they'll get nice ones with a sealing gasket on it. I don't have that, but this is just for demonstration purposes. And then what you can do is you'll create a small hole to feed in your sensor. So let's say this is inside here, and you might, again, want to use a little rubber grommet to keep a really nice tight seal on that. And then you can go and plug your Pi badge in there and check out the humidity and temperature inside. So what people will often do is include some little silica desiccant so that it absorbs moisture. And this could be just something you go and spot check. These are inexpensive. Like I mentioned, these are on sale right now during the live stream for $4.05. So you could potentially build these into a couple of bins and then go around with your Pi badge and just plug in and check. If you want to do something a little more like an alert system, one thing you'll notice that I created here are some thresholds. And so right now my temperature threshold is set, I think I had it set at 74. So right now these LEDs are lit red to tell me we're beyond the temperature threshold that I wanted. If we swap back over to humidity, right now we're below the humidity threshold that I wanted. But as I, again, fog this up, you'll see my lights go red when it gets too humid. And then they drop back down to blue when it drops back down to the humidity that I wanted at. So this is a sort of fun and simple way to demonstrate this. And what I'd like to do is show you a bit of the code that goes into this, just to show you how easy it is to program this in CircuitPython. So what I'm going to do is I'm going to open up my code editor, and let's find that here. Oh, we've lost the... All right, one second. We're going to go into a black hole here while I fix this screen capture. Boy, I'll tell you, one crash and it takes out a lot. Okay, let's give that a second to catch up. Oh, it looks like it doesn't want to. All right, I'm going to build a new window. Pardon me again. Let's do a new screen capture. It's always an adventure with live streaming. Okay, new black hole. 1 second. We can do it. There we go. All right, so I'm just going to shoot that over here, and I think I'll scale this down a bit, and you should still be able to read it, but I want you to see the serial port. So here we go. Let's, yeah, I won't push my luck and add any more windows, will I? Okay, yes, I will. I lied. There we go. So here we have my code in CircuitPython, and you'll see what I'm doing is I'm bringing in some libraries to deal with the Pygamer, mostly stuff with buttons and display. And then at the bottom here, I'm importing this library, the Adafruit AHT20. This is the, or AHT0. This is the 20 that we have. We set this up on the I2C bus on the board, which is simply where we are going to do this communications with data and clock. It's a clock synced data protocol. And we have power and ground on that as well to power up the board. And then you can see here I set some of those thresholds that I mentioned before. My max level in Celsius, my max level in humidity percentage. We're setting up some buttons to use, and then some colors and text to display. And then I'm setting up the button as this gamepad that Melissa helped me out with, actually. A really convenient way to use the buttons. And then when we get down to setting up our actual value reads, you'll see here, this is in the main loop. And this is quick and dirty code. It's not optimized, but hopefully it's clear. And I just wrote this yesterday very quickly. And what's going on is I am checking the buttons to see if they've been pressed with a little bit of a debounce. And then I check to see if I have exceeded the maximum temperature and the maximum humidity as a sort of a state that I can turn on and off. And if I have, I set those neopixels to the right color. And then here's the, when I press a button to switch between modes, here's the main thing that happens. We go, we change some of the display graphics here. And then this is the sensing. This is as easy as it gets. This is how you check that sensor, sensor.temperature. That reads out the temperature for you in Celsius. I can scroll over here a little bit so you can see that better. And then with humidity, it's this, let me drop down, relative humidity is what we're checking, sensor.relative humidity. And you can see I have some, a little bit of text fanciness going on here to format it nicely. And that is it. And then I also have a little bit of code there to convert between Fahrenheit and Celsius, depending. So we'll use this if we're in Fahrenheit mode. And what I wanted to show you, if I can get to the terminal, the serial output of the Pygamer here, what we should see is when I cross that threshold, I just have it printing when I cross that threshold. There it says, too humid. So this was just a little test I had for myself. What I'll do now is comment out this temperature and this humidity line. Actually, let's just look at the humidity one. And I'll resave my code. And let's save that to the actual board. I'm just going to overwrite that. Yes. It's booting back up, and there you can see we're polling that humidity. So it polls very quickly. I even have some of my own delays that are caused by the printing to the display. But if I breathe on this again, you see it goes up very quickly and it falls very quickly. If I hold this in my hands, now I've got it held in my hands and I've got sort of a little moisture chamber. Ugh, that's kind of gross. But as let me show you the moisture chamber here. Let's see. There's the humidity is at 100% because this is in my hands and I breathed on it. If I let this out into the dry air, boom, it drops very quickly. So You can imagine you could use this type of sensor for things like electronics. As a matter of fact, my friend Todd was telling me that the static electricity buildup is tremendous at certain thresholds of humidity, like 0 to 20%, and way, way less voltage at higher humidities. So it's something people care about for electrostatic discharge, as well as musical instruments, 3D printer filament, foods. There's a whole lot of use cases where you'd want to deal with the humidity sensing. If we take a look, and again, and pardon me, I'm going to try to refresh my browser here. Actually, you know what? I'm gonna cheat, and I'm just gonna move this in front of everything. Let's see if it updates. Does it want to update? No, it doesn't. All right. Let me make a new screen capture. And again, I'm sorry, this is going to go long just because of my technical challenges we had with that crash. But what I'll show you is the Learn Guide, and also link in the Learn Guide to the data sheet, which will tell you what some of the manufacturer's use cases are. So one moment, I'll bring in a Chrome. And also, if I go long, you're getting extra time to go and get that extra good deal on the board. So let's scale this down just a little bit for you. There we go. So here you can see, again, we still have our special pricing. You can watch the show right inside of there. If we click down on this guide link, this will take us to the Learn Guide for the AHT20. Definitely check this out. If we head down to the downloads, the last page, you'll see there's a data sheet page here. And if I click on that, we go to the manufacturer's data sheet. And you'll see here is a little application scope section. I always find these interesting. So HVAC systems, dehumidifiers, test and inspection equipment, consumer goods, cars, weather stations, household appliances, medical equipment. Those are all cases where you might be interested in using a small, inexpensive temperature and humidity sensor. And so that's going to do it for today. That is my...
And then last up to start the show, besides...
Wrong button. That is my pick of the week. It is this lovely AHT20 Temperature and Humidity Sensor. It's product ID 456. And apparently that's a highly cursed image, and I really need to stop trying to show it. So I will just say thank you for stopping by to see JP's product pick of the week. And I'm going to go ahead and do my ceremonial moving of the AHT20 sensor to the pegboard of Stemma QT goodness. And that's going to do it for this week. I will see you next time. Go ahead to that product page real quick because that deal is about to expire. And have a great week. See you next week.